All right, so with problem 8, we are using implicit differentiation. So to do that, what we do is that, so we have the main problem is xy plus y to the power 5 equal to 6. Now, since we are using implicit differentiation, for us to differentiate this, what you need to apply the product rule here. So what happens is that first we can cover the x, then we differentiate y, or whichever way we want to do it, or we can cover the y and differentiate x. So first let's cover the y and differentiate x, and that gives us y. Then when we cover x and we differentiate y, we'll get the y dx. Then when we also differentiate y to the power 5, we're going to have 5y to the power 4. Then we attach the y dx. Then when we differentiate 6, we get 0. Now, I attach the y dx in the sense, I attach the y dx to 5y to the power 4, and that's what the rule says. It says that anytime in the use of implicit differentiation, it says that anytime we differentiate with respect to y, we always have to attach the factor dy dx. So we always have to bear this in mind, that if you want to differentiate y, you always have to attach a factor of dy dx. Is that okay? Right. So at this point, what we do is to group the dy dx. So we should factor them, in other words. So what we do is to factor the dy dx. So at this point, what you need to do is to group the dy dx at one point. So with that, we're going to group, then we factor that out. So with that, we're going to have our dx, our x dy dx plus 5 to the power 4 dy dx equal to minus y. Now, what we need to do is to factor dy dx on the left. So with that, we're going to have dy dx sitting outside, then you have x plus 5 to the power 4, or equal to -4. So at this point, all that we need to do is to make sure that the dy dx stands alone. So with that, we're going to have minus y, or on x plus 5 to the power 4. So this gives us the final result. Now, with this problem, which is problem 9, it's an optimization problem. It's an optimization problem. So what basically we do is that, so we are given this problem to maximize. We are to maximize p equal to 6s plus y, which is subject to this constraint. Now the question is, what then is the maximum value of p? So that's of interest to us. So how do we approach this? So for us to do this, remember we are having to two variables which are x and y. So we have to try our best possible to change the constraint, or to rely on the constraint and make one variable the subject, so that we can work with only one variable instead of the two variables. So in this case, what we're going to do is that we can decide to make y the subject. So I will say that from x squared plus y equal to 3, this implies that y should be equal to 3 minus x squared. Then afterwards, we are going to, what we're going to do, we are going to put this one into the maximization problem. Okay, so I will say that, let me call this one. So let me use star. So I will say that put star, or substitute, let me use the word substitute. So substitute star into P equal to 6x plus y. Now, when we do the substitution, it implies that, or we are going to obtain 6x plus. Now, wherever we see y in this problem, we are going to replace it by this quantity. So you're going to have 6x plus 3 minus x squared. Now, there's a problem we are going to work with. So now we are going to work with this problem. Now, the question is, how do we solve maximization problem? So the first thing to do is to what? Is to find the critical values. How do you find the critical values? So to find the critical values, we find the derivatives and set it to 0. So we find the first derivative and set it to 0. Then we set to 0. So this implies that my x will just be 3. Now, remember that with the maximization problem, for maximum, so let's try to find a second derivative. So for the second derivative, we are going to have -2. And we claim that since it is less than 0, it means that since it's less than 0, then we can talk about what? Maximum, if you could remember. And we evaluated that x is equal to 3, then we are talking about maximum. But then to find its value, what we need to do is that we set this, we substitute this x equal to 3 into the main problem. So with that, substituting x equal to 3 into yields. So we substitute 3 into that yields. Just gives you the result. So this brings us to the end of this particular problem. So with problem 12, so with the problem 12, what we're going to do is to find the critical values, or the critical points of any function. We said that we find the first derivative, then we set to 0. So find the first derivative, and that gives us 3x squared minus 3. Then we set to 0. So when you set to 0, then we are going to have x equal to plus or minus 1. So we have plus x is equal to plus or minus 1. So these are the critical points. Now, since we want to use the second derivative test to determine the relative extrema, what we need to do is that we find the second derivative of this function. And the second derivative, we're going to have 6x. Now, since we are looking at the relative extrema, now we need to evaluate this second derivative at the critical point. So let's pick the first one, which is 1. So that gives us 6. So if it's 6, then we will be talking about minimum. Then if we evaluate this and we get -6, of which we are going to get -6, then we'll be talking about relative maximum. Now, but these are not all. What we need to do at the end of the day, we need to sort of find the values. Okay, so we are finding the relative. So having determined whether it's minimum or maximum, we need to find the corresponding values. So what we need to do is to substitute this particular one into the main function. So substitute 1. So we substitute 1 into the original function to obtain the overall value for the minimum. And that will give you the answer. And I think that should give you, so 1 minus 3, which is -2, so -2 plus that, which is 0, right? And then -1 should give us so that gives us -1 plus 3 plus 1 plus 2. And that should give us what? 4. And I believe at this point, everybody is getting it. So implicit function, this is another interesting problem that I think we should try to understand how to use the implicit function. But this is another area that I believe everybody should understand. So we're given y to the power 3 plus x squared y to the power 4 minus s to the power 4 equal to 27. Now using the implicit function, as we said, that anytime we differentiate the y, we always have to attach the y dx. So when we differentiate this, we're going to have 3y squared dy dx plus, and over here, the second term here, which is x squared plus y to the power 4, we use the product rule. So with that, we're going to have 2x y to the power 5 plus 5x squared y to the power 4 dy dx minus 4x to the power 3 equals to 0. Remember, anytime we differentiate a constant, which in our case is 24, and 27, and that one differentiate we get 0. So that's the more reason why we have 0 on the right hand side. Now, this one, what we do is to group the dy dx together. So by grouping them, see, we have these ones are together, so we can just group them. So when we group them, we're going to have 3y squared divided x plus 5x squared y to the power 4 divided x equal to, then we try to move these two to the other side. These two, we try to move them. So we try to move these two to the other side. So that gives us 4x cubed minus 2xy to the power 5. Then we group the dy dx together. So by doing so, we're going to have something like this. So this then becomes our final answer. But I should say that the exam tomorrow is just going to be like the review problems that I've submitted with, which some are just the same as what we are solving right now. So I just want to wish you guys the best, and I'll see you tomorrow. Okay, bye-bye.